Hey guys, welcome back to my channel. The topic that we are going to discuss today is chemistry part 2 polymers. So as this chapter is very theoretical, it is very important कि हम इसको बहुत बार रिवाइज करें. तो आप हो सके तो इसको जितनी बार इस ऑडियो बुक को सुन सको उतनी बार सुनो. आप चल रहे हो, ट्रैवल कर रहे हो या फिर मेट्रो में हो, तो इंस्टेड ऑफ जस्ट वेस्टिंग योर टाइम आप ये ऑडियो बुक ऑन कर लो और थोड़ा ध्यान लगा के इसको सुन लो, तो आपका रिविजन बहुत अच्छा हो जाएगा. ठीक है. So without wasting any time, let's get started with our chapter, that is polymers. Chapter 15, Polymers. Do you think that daily life would have been easier and colorful without the discovery and varied application of polymers? The use of polymers in the manufacture of plastic buckets, cups and saucers, children's toys, packaging bags, synthetic clothing materials, automobile tires, gears and seals, electrical insulating materials, and machine parts has completely revolutionized the daily life as well as the industrial scenario. Indeed, the life as well as Indeed, the polymers are the backbone of four major industries, that is plastic, elastomers, fibers, and paints and varnishes. The word polymer is coined from two Greek words. Poly means many and mer means unit or part. The term polymer is defined as very large molecules having high molecular mass ranging from 10 raised to 3 to 10 raised to 7 unified mass. These are also referred to as macromolecules, which are formed by joining of repeating structural units on a large scale. The repeating structural units are derived from some simple and reactive molecules known as monomers and are linked to each other by covalent bonds. The process of formation of polymers from respective monomers is called polymerization. Classification of polymers. There are several ways of classification of polymers based on some special considerations. One of the common classification of polymer is based on source from which polymer is derived. Under this type of classification, there are three subcategories. First, natural polymers. These polymers are found in plants and animals. Examples are proteins, cellulose, starch, some resins, and rubber. Second, semi-synthetic polymers. Cellulose derivatives as cellulose acetate, rayon, and cellulose nitrate, etc. are the usual examples of this subcategory. Third, synthetic polymers. A variety of synthetic polymers as plastic, polythene, synthetic fibers, nylon 66, and synthetic rubbers, that is Buna S, are examples of man-made polymers extensively used in daily life as well as in industry. Polymers can also be classified on the basis of their structure, molecular forces, or mode of polymerization. Types of polymerization reactions. There are two broad types of polymerization reaction, that is the addition or chain growth polymerization and condensation or step growth polymerization. Addition polymerization or chain polymerization. In this type of polymerization, the molecules of same monomer or different monomers add together on a large scale to form a polymer. The monomers used are unsaturated compounds, example alkenes, alkynes, and their derivatives. This mode of polymerization leads to an increase in chain length, and chain growth can take place through the formation of either free radicals or ionic species. However, the free radical governed addition or chain growth polymerization is the most common mode. Mechanism of addition polymerization. Free radical mechanism. A variety of alkenes or dienes and their derivatives are polymerized in the presence of free radical generating initiator, that is catalyst like benzoyl peroxide, acetyl peroxide, tert butyl peroxide, etc. For example, the polymerization of ethene to polythene consists of heating or exposing to light a mixture of ethene with a small amount of benzoyl peroxide initiator. The process starts with the addition of phenyl free radical formed by the peroxide to the ethene double bond, thus generating a new and a larger free radical. This step is called chain initiating step. As this radical reacts with another molecule of ethene, another bigger size radical is formed. The repetition of this sequence with new and bigger radicals carries the reaction forward, and the step is termed as chain propagating step. Ultimately, at some stage, the product radical thus formed reacts with another radical to form the polymerized product. This step is called the chain terminating step. The sequence of steps involved in the formation of polythene are depicted as follows. First is the chain initiation step. तो you can see देखो benzoyl peroxide जो है वो ब्रेक होके radical form में बन जाता है and finally it breaks into phenyl radical and CO2 gets released. Then the alkene attacks on the phenyl radical and फिर ये phenyl ethene करके ethene radical बन जाता है. And then वही chain propagating step, it can be seen on the screen, so you can go through it. Chain terminating step. For termination of the long chain, these free radicals can combine in different ways to form polythene. One mode of termination of chain is shown as under. So you can see कैसे chain terminate हो जा रही है and the polythene is formed. The addition polymers formed by the polymerization of a single monomeric species are known as homopolymers. For example, polythene discussed above is a homopolymer. The polymers made by addition polymerization from two different monomers are termed as copolymers. तो दो टाइप के हमारे पास polymers है, एक homopolymers है और एक copolymers है. Homopolymers में क्या है, सिंगल मोनोमेरिक स्पीशीज, मतलब वही यूनिट क्या होगी, रिपीट होगी. लेकिन कोपॉलीमर में क्या होगा, अलग दो टाइप के डिफरेंट यूनिट क्या होगा, रिपीट होगा. तो उसका एग्जाम्पल क्या है, ब्यूना एस विच इज फॉर्म्ड बाय पॉलीमराइजेशन ऑफ ब्यूटा 1,3 डाइन एंड स्टीरीन इज एन एग्जाम्पल ऑफ कोपॉलीमर फॉर्म्ड बाय एडिशन पॉलीमराइजेशन. तो ये देखो 1,3 ब्यूटाडाइन दिख रहा है आपको स्क्रीन पे, उसके साथ क्या जुड़ा हुआ है, स्टीरीन जुड़ा हुआ है एंड स्टीरीन ये दोनों जुड़ के क्या बना रहे हैं, ब्यूटाडाइन स्टीरीन कोपॉलीमर या फिर उसको ब्यूना एस भी बोलते हैं. ठीक है. Some important addition polymers. First, polythene. Polythenes are linear or slightly branched long chain molecules. These are capable of repeatedly softening or heating and hardening on cooling and are thus thermoplastic polymers. There are two types of polythene as given below. First is low density polythene. It is obtained by the polymerization of ethene under high pressure of 1000 to 2000 atmospheres at a temperature of 350 Kelvin to 570 Kelvin in the presence of traces of dioxygen or a peroxide initiator, that is catalyst. The low density polythene LDP is obtained through the free radical addition and hydrogen atom abstraction. It has highly branched structure. These polymers have straight chain structure with some branches as shown below. Low density polythene is chemically inert and tough but flexible and poor conductor of electricity. Hence, it is used in the insulation of electricity carrying wires and manufacture of squeeze bottles, toys, and flexible pipes. High density polythene, it is formed when addition polymerization of ethene takes place in a hydrocarbon solvent in the presence of a catalyst such as triethyl aluminum and titanium tetrachloride Ziegler-Natta catalyst at a temperature of 333 Kelvin to 343 Kelvin and under a pressure of 6 to 7 atmosphere. High density polythene HDP thus produced consists of linear molecule as shown below and has a high density due to close packing. Such polymers are also called linear polymers. High density polymers are also chemically inert and more tough and hard. It is used for manufacturing buckets, dustbins, bottles, पाइप्स एक्सेट्रा. तो देखो ये चैप्टर में यहाँ पर क्या इंपॉर्टेंट होगा, आपको ना कोई भी एग्जांपल दे देगा, बोलेगा एचडीपी कहाँ पर यूज़ होता है, मतलब किस लिए मैन्युफैक्चर होता है, या फिर एलडीपी किस लिए मैन्युफैक्चर होता है, या फिर इट कैन बी स्टेटमेंट इट इज़ यूज्ड इन मैन्युफैक्चर ऑफ बकेट, डस्टबिन, बॉटल, पाइप्स एंड 4 ऑप्शन देगा एचडीपी, एलडीपी, XYZ. तो उस तरह से हमें पहचानने आना चाहिए. नेक्स्ट, पॉलीटेट्राफ्लोरोइथेन दैट इज टेफ्लॉन. Teflon is manufactured by heating tetrafluoroethene with a free radical or persulfate catalyst at high pressures. It is chemically inert and resistant to attack by corrosive reagents. It is used in making oil seal and gaskets and also used for non-stick surface coated utensils. तो आपको दिख रहा है CF2 डबल बॉन्ड CF2, इसको क्या बोलते हैं, टेट्राफ्लोरो इथीन. कैटलिस्ट लगेगा, हाई प्रेशर लगेगा और बन क्या जाएगा, टेफ्लॉन. Polyacrylonitrile. The addition polymerization of acrylonitrile in presence of a peroxide catalyst leads to the formation of polyacrylonitrile. Polyacrylonitrile is used as a substitute for wool in making commercial fibers as Orlon और acrylic. तो ये देखो ना, polyacrylonitrile wool को replace कर सकता है. ठीक है. Let's move to the next part. Condensation polymerization or step growth polymerization. This type of polymerization generally involves a repetitive condensation reaction between two bifunctional or trifunctional monomeric units. These polycondensation reaction may result in the loss of some simple molecules as water, alcohol, hydrogen chloride, etc. and lead to the formation of high molecular mass condensation polymers. In these reactions, the product of each step is again a bifunctional species and the sequence of condensation goes on. Since each step produces a distinct functionalized species and is independent of each other, this process is also called as step growth polymerization. The formation of pterilene or dacron by the interaction of ethylene glycol and terephthalic acid is an example of this type of polymerization. तो यहाँ पर देखो हमको दिख रहा है इथिलीन ग्लाइकॉल, जिसको हम बोलते हैं इथीन 1,2 डायोल, एंड देयर इज टेरेप्थैलिक एसिड या फिर बेंजीन 1,4 डाइकार्बोक्सिलिक एसिड, और उससे बन के आ गया टेरिलीन या फिर डेक्रॉन. तो ये कैसा टाइप का पॉलीमर है? इट इज़ अ कंडेंसेशन पॉलीमराइजेशन. यहाँ पर रिमूवल किस चीज़ का हुआ है? वाटर मॉलिक्यूल का रिमूवल हुआ है. Some important condensation polymers. First, it is polyamides. These polymers possessing amide linkages are important example of synthetic fibers and are termed as nylons. The general method of preparation consists of the condensation polymerization of diamines with carboxylic acid or condensation of amino acid or their lactams. Nylons. First, nylon 6,6. It is prepared by condensation polymerization of hexamethylene diamine with adipic acid under high pressure and at high temperature. तो आप यहाँ पर देख लो, देखो हेक्सामिथिलीन हमने लिया है और उसको रिएक्ट करवाया किससे? एडिपिक एसिड से, और फिर हाई टेम्परेचर पे क्या हो जाएगा? नाइलॉन 6,6 बन जाएगा. Nylon 6,6 is a fiber forming solid. It possesses high tensile strength. This characteristic can be attributed to the strong intermolecular forces like hydrogen bonding. These strong forces also lead to close packing of chains and thus impart crystalline nature. Nylon 6,6 is used in making sheets, bristles for brushes and in textile industry. तो अभी आप नेक्स्ट टाइम ब्रश करोगे ना तो बार बार याद करना कि अरे जो मेरा ब्रश बना है वो किससे बना है? नाइलॉन 6,6 से बना है. किससे बना है? नाइलॉन 6,6 से. Nylon 6. It is obtained by heating caprolactam with water at high temperature. तो हमारे पास क्या है? देखो कैप्रोलैक्टम है और उसको हाई टेम्परेचर पे हीट किया तो फिर क्या बन जाएगा? नाइलॉन 6. नाइलॉन 6 इज यूज फॉर मैन्युफैक्चर ऑफ टायर कॉर्ड्स, फैब्रिक्स एंड रोप्स. तो ये नाइलॉन के जो भी जितने भी वायर्स होते हैं ना वो इतने मतलब तगड़े होते हैं ना. बीच में दिल्ली में केस भी आया था कि बर्ड्स भी कट के मर गए थे. सो दिस इज हाउ टफ दे आर, मतलब इतना शार्प होता है. Okay, polyesters. These are the polycondensation products of dicarboxylic acids and diols. Dacron or terylene is the best known example of polyesters. It is manufactured by heating a mixture of ethylene glycol and terephthalic acid at 420 to 460 Kelvin in the presence of zinc acetate antimony trioxide catalyst, as per the reaction given earlier. Dacron fiber terylene is crease resistant and is used in blending with cotton and wool fibers and also as glass reinforcing materials in safety helmets. Phenol, formaldehyde polymer, bakelite and related polymers. Phenol formaldehyde polymers are the oldest synthetic polymers. These are obtained by the condensation reaction of phenol with formaldehyde in presence of either an acid or a base catalyst. The reaction starts with initial formation of ortho and or para-hydroxymethyl phenol derivatives which further react with phenol to form compounds having rings joined to each other through CH2 groups. The initial product could be a linear product, Novolac used in पेंट्स. तो आप लोग ये मैकेनिज्म देख लो कैसे हो रहा है. या तो आप एसिड कैटलिस्ट भी ले सकते हो और बेस कैटलिस्ट. एनीथिंग विल वर्क इन फॉर्मेशन ऑफ अ नोवोलैक. नोवोलैक ऑन हीटिंग विथ फॉर्मल्डिहाइड undergoes cross-linking to form an infusible solid mass called bakelite. It is thermosetting polymer which cannot be reused or remolded. Thus, bakelite is formed by cross-linking of linear chains of polymer novolac. Bakelite is used for making combs, phonograph records, electrical switches and handles of various utensils. So here you can see the structure of bakelite, novolac से कैसे बना वो, ठीक है. Next, melamine formaldehyde polymer. Melamine formaldehyde polymer is formed by condensation polymerization of melamine and formaldehyde. तो melamine और formaldehyde को condense कर दिया तो resin intermediate मिला and then finally melamine का polymer बन गया. It is used in manufacture of unbreakable crockery. ठीक है, तो अगर अभी अनब्रेकेबल क्रॉकरी जो है वो याद रखना पड़ेगा किससे बना है, मेलामाइन फॉर्मल्डिहाइड पॉलीमर्स से. Copolymerization. Copolymerization is a polymerization reaction in which a mixture of more than one monomeric species is allowed to polymerize and form a copolymer. The copolymer can be made not only by chain growth polymerization but by step growth polymerization also. It contains multiple units of each monomer used in same polymeric chain. For example, a mixture of buta-1,3-diene and styrene can form a copolymer. जो हमने स्टार्टिंग में डिस्कस किया था कि ब्यूटाडाइन ले लो, स्टीरीन ले लो तो क्या बन जाएगा, ब्यूनाइस बन गया था, right? Copolymers have properties quite different from homopolymers. For example, butadiene styrene copolymer is quite tough and is a good substitute for natural rubber. It is used for manufacture of auto tires, floor tiles, footwear components, cable insulation, etc. Rubber. Natural rubber. Rubber is a natural polymer and possesses elastic properties. It is also termed as elastomeric polymer. In elastomeric polymers, the polymer chains are held together by weak intermolecular forces. These weak binding forces permit the polymer to be stretched. A few crosslinks are introduced in between the chains which help the polymer to retract to its original position after the force is released. Rubber has a variety of uses. It is manufactured from rubber latex, which is a colloidal dispersion of rubber in water. This latex is obtained from the rubber tree which is found in India, Sri Lanka, Indonesia, Malaysia and South Africa. Natural rubber may be considered as a linear polymer of isoprene, 2-methyl-1,3-butadiene. तो isoprene क्या है, 2-methyl-1,3-butadiene and is also called as cis-1,4-polyisoprene. So here you can see isoprene का structure and you can also see natural rubber कैसे दिखता है, ठीक है. The cis-polyisoprene molecule consists of various chains held together by weak van der Waals interactions and has a coiled structure. Thus, it can be stretched like a spring and exhibits elastic properties. Vulcanization of rubber. Natural rubber becomes soft at high temperature, that is more than 335 Kelvin, and brittle at low temperature, that is less than 283 Kelvin, and shows high water absorption capacity. It is soluble in non-polar solvents and is non-resistant to attack by oxidizing agent. To improve upon these physical properties, a process of vulcanization is carried out. This process consists of heating a mixture of raw rubber with sulfur and an appropriate additive at a temperature range between 373 Kelvin to 415 Kelvin. On vulcanization, sulfur forms cross links at the reactive sites of double bonds and thus the rubber gets stiffened. In the manufacture of tire rubber, 5% of sulfur is used as a cross-linking agent. The probable structures of vulcanized rubber molecules are depicted below. You can see how the rubber is vulcanized. ठीक है, 5% सल्फर यूज करते हैं, ये इंपॉर्टेंट है। टायर रबर में 5% क्या होता है सल्फर, मेरे टायर के रबर में कितना सल्फर है 5%। Next, synthetic rubbers. Synthetic rubber is any vulcanizable rubber like polymer which is capable of getting stretched to twice its length. However, it returns to its original shape and size as soon as the external stretching force is released. Thus, synthetic rubbers are either homopolymers of 1,3-butadiene, derivatives or copolymers of 1,3-butadiene, or its derivatives with another unsaturated monomer. Preparation of synthetic fibers. First, neoprene. Neoprene or polychloroprene is formed by the free radical polymerization of chloroprene. तो क्लोरोप्रीन को हमने क्या कर दिया, फ्री रेडिकल मैकेनिज्म से पॉलीमराइज किया तो नियोप्रीन बन जाएगा, ठीक है। सिर्फ स्ट्रक्चर में थोड़ा सा अदला बदली है, बाकी कुछ चेंज नहीं है। और क्लोरोप्रीन को क्या बोलते हैं, 2-क्लोरो 1,3-ब्यूटा 1,3-डाइन, ठीक है। इट हैज सुपीरियर रेजिस्टेंस टू वेजिटेबल एंड मिनरल ऑयल्स. इट इज यूज्ड फॉर मैन्युफैक्चरिंग कन्वेयर बेल्ट्स, gaskets and hoses. Buna N. You have already studied about Buna S in section 15.1.3. Buna N is obtained by copolymerization of 1,3-buta 1,3-diene and acrylonitrile in the presence of peroxide catalyst. तो देखो 1,3-ब्यूटाडाइन यहाँ पर एंड एक्राइलोनाइट्राइल, उसका कोपॉलीमराइजेशन क्या तो ब्यूनाइन बनता है। एक्राइलोनाइट्राइल तो आपको पता है साइनाइड होता है उसमें। It is resistant to the action of petrol, lubricating oil and organic solvent. It is used in making oil seals, tank linings, etc. Molecular mass of polymers. Polymer properties are closely related to their molecular mass, size and structure. The growth of the polymer chain during their synthesis is dependent upon the availability of the monomers in the reaction mixture. Thus, the polymer sample contains chains of various length and hence its molecular mass is always expressed as an average. The molecular mass of polymers can be determined by chemical and physical methods. A large number of polymers are quite resistant to the environmental degradation process and are thus responsible for accumulation of polymeric solid waste materials. These solid waste cause acute environmental problems and remain undegraded for quite a long time. In view of general awareness and concern for the problems created by polymeric solid waste, certain new biodegradable synthetic polymers have been designed and developed. These polymers contain functional groups similar to the functional group present in biopolymers. Aliphatic polyesters are one of the important classes of biodegradable polymers. Aliphatic polyesters, ठीक है? Some important examples are given below. Beta hydroxybutyrate, को बीटा हाइड्रोक्सी वैलेरेट, जिसको हम बोलते हैं PHBV. It is obtained by the copolymerization of 3-hydroxybutanoic acid and 3-hydroxypentanoic acid. PHBV is used in specialty packaging, orthopedic devices, and in controlled release of drugs. PHBV undergoes bacterial degradation in the environment. Second, nylon 2, nylon 6. It is an alternating polyamide copolymer of glycine and aminocaproic acid and is biodegradable. Can you write the structure of this copolymer? Polymers of commercial importance. Besides the polymers already discussed, some other commercially important polymers along with their structures and uses are given below in table 15.1, which comprises of some other commercially important polymers. ठीक है, तो ये टेबल जो हमारे दिख रहा है स्क्रीन पे वो बहुत इंपॉर्टेंट है एग्जाम पॉइंट ऑफ व्यू से, क्योंकि डायरेक्टली क्वेश्चंस उठ के चले आते हैं. ठीक है, तो आई विल जस्ट रीड द नेम ऑफ पॉलीमर, उसका मोनोमर क्या है, स्ट्रक्चर आपको स्क्रीन पे दिख जाएगा एंड मैं उसका यूजेस बताऊंगी. ठीक है, तो फर्स्ट पॉलीमर इज पॉलीप्रोपीन. तो उसका मोनोमर यूनिट क्या है, देखो पॉलीप्रोपीन है तो मोनोमर फॉर श्योर क्या होगा, प्रोपीन, अकेला प्रोपीन. स्ट्रक्चर, प्रोपीन का स्ट्रक्चर आप सबको पता है क्या हो जाएगा, CH2CH, ऊपर जाएगा CH3 एंड सेंटर से क्या होगा, बॉन्डिंग होगी. ठीक है, आप यू कैन सी ऑन द स्क्रीन. ठीक है, यूजेस मैन्युफैक्चर ऑफ रोप्स, टॉयज, पाइप्स, फाइबर्स एक्सेट्रा. नेक्स्ट पॉलीमर इज पॉलीस्टीरीन. पॉलीस्टीरीन है तो मोनोमर आप बताइए. स्टीरीन. यू कैन सी द स्ट्रक्चर ऑफ स्टीरीन. CH2CH ऊपर C6H5. क्या बोला मैंने? CH2CH ऊपर C6H5. its uses are as insulator, wrapping material, manufacture of toys, radio and television cabinets. नेक्स्ट पॉलीमर इज पॉलीविनाइल क्लोराइड. नाम क्या है? पॉलीविनाइल क्लोराइड. तो मोनोमर आपको डायरेक्टली समझ में आ रहा है भाई, पॉली तो ऑलरेडी है तो विनाइल क्लोराइड क्या है? मोनोमर है. तो CH2CH ऊपर क्या? Cl. CH2CH ऊपर क्या? Cl. n नंबर ऑफ टाइम्स रहेगा. ठीक है. यूजेस क्या हो जाएगा PVC का? मैन्युफैक्चर ऑफ रेनकोट्स, हैंडबैग्स, विनाइल फ्लोरिंग, वाटर पाइप्स. तो हमारे घर में जो पाइप्स होती हैं, या फिर हम बोले जो रेनकोट में पहन के स्कूल जाती हूँ, तो वो सारे क्या हैं? PVC के बने हुए. नेक्स्ट, यूरिया फॉर्मल्डिहाइड रेजिन. यूरिया फॉर्मल्डिहाइड रेजिन बोलते हैं उसको. ठीक है. तो किस मोनोमर यूनिट क्या होगा? यूरिया एंड फॉर्मल्डिहाइड. यू कैन सी द स्ट्रक्चर. NH C डबल बॉन्ड O NH CH2. ठीक है. यूजेस फॉर मेकिंग अनब्रेकेबल कप्स एंड लैमिनेटेड शीट्स. ग्लिप्टिल. ग्लिप्टिल किससे बना हुआ है? इथिलीन ग्लाइकॉल से एंड थैलिक एसिड से. तो मोनोमर यूनिट ग्लिप्टिल का क्या है? इथिलीन ग्लाइकॉल एंड थैलिक एसिड. सो यू कैन सी द स्ट्रक्चर ओवर हियर. इथिलीन ग्लाइकॉल का स्ट्रक्चर एंड फिर थैलिक एसिड का स्ट्रक्चर, दोनों कंटिन्यूएशन में है. इट इज यूज्ड इन मैन्युफैक्चर ऑफ पेंट एंड लैकर्स. तो घर में पेंट है तो अब मैं बोलूँगी एशियन पेंट नहीं, ग्लिप्टिल पेंट. ग्लिप्टिल में कौन? इथिलीन ग्लाइकॉल एंड थैलिक एसिड. बेकेलाइट. It is made up of phenol and formaldehyde for making combs, electrical switches, handles of utensils and computer disk. तो रोज हम कंघी करते हैं ना, तो बेकेलाइट से बनी हुई कंघी. ओके, लेट्स रीड द समरी. Polymers are defined as high molecular mass macromolecules which consist of repeating structural units derived from corresponding monomers. These polymers may be of natural or synthetic origin and classified in number of ways. In the presence of an organic peroxide initiator, the alkenes and their derivatives undergo addition polymerization or chain growth polymerization through a free radical mechanism. Polythene, Teflon, Orlon, etc. are formed by addition polymerization of an appropriate alkene or its derivative. Condensation polymerization reactions are shown by interaction of bi or polyfunctional monomers containing NH2, OH and C double bond OH groups. This type of polymerization proceeds further through the elimination of certain simple molecules like water or methyl alcohol, etc. Formaldehyde reacts with phenol and melamine to form the corresponding condensation polymer products. The condensation polymerization progresses through step by step and is called as step growth polymerization. Nylon, bakelite and dacron are some of the important examples of condensation polymers. However, a mixture of two unsaturated monomers exhibits copolymerization and forms a copolymer containing multiple units of each monomer. Natural rubber is a cis 1,4-polyisoprene and can be made more tough by the process of vulcanization with sulfur. Synthetic rubbers are usually obtained by copolymerization of alkenes and 1,3-butadiene derivatives. In view of potential environment hazards of synthetic polymeric waste, certain biodegradable polymers such as PHBB and nylon 2, nylon 6 are developed as alternatives. So here we complete the chapter polymers. I hope you enjoyed listening to the audio. So if you like the video, please hit the like button, subscribe to the channel and keep studying. Bye bye. Thank you so much for watching.